Well, hello there, back for combinations and permutations. Let's see what we can find out about those. Well, number one, now this goes back a ways because we're going to use the calculator for most of this stuff, but a factorial, just for general information, is the product of the integers starting at 1, or I should say the whole numbers, from 1 up until a certain place. So if you had 5 factorial, it would be 1 times 2 times 3 times 4 times 5. This definition does it sort of the opposite way. That's okay. Let's get the pen going here. There we go. You ready? Well, let's go. Alright. One of the odd things about factorials, maybe the oddest thing, is that 0 factorial is defined to be 1. Now, there's a reason for that. If you're really interested, I could show you an example in a minute or two in class. Just bring it up, no problem. Otherwise, we'll just say that's what 0 factorial is, and we'll move on. So here are some factorial expressions you can practice for yourself. If you want to check out this first one, let me get something out of my way. There we go. Alright, 7 factorial. Remember that's 1 times 2 times 3 times 4 times 5 times 6 times 7. What's the short way of doing it? Here's the TI-84 explanation. Hit the math key, go over to probability, all caps. Number 4 is for the exclamation point, which means it's going to do the factorial. So if you want to do this, the easy way, type 7 into your calculator, go to math, probability, hit 4 for the factorial. I'll give you this on the main screen, hit enter, and you'll get your answer. For the second one, well, first of all, we know this is equal to 1, so you don't even need to fool around with that. All you need to do is get 4 factorial. Now you could take 1 times 2 times 3 times 4, not too bad, or you can do it this way. Now, if you forgot and wanted to do it the harder way, putting 4 factorial over 0 factorial, just remember first, hit the alpha key, the y equals key, and then enter. And that will give you a template for a fraction like we have here. Put the 4 factorial on the top, 0 factorial on the bottom, and you get your answer. The same thing with 65 factorial over 63 factorial, and so on. Now, take this one for example. Now, this one is here for a particular reason. If you know what 65 factorial means, and your calculator will do that, it's 1 times 2 times 3 times 4, all the way up to 65. Well, if you start by 65 times 64, now, think a second. The rest of them is going to be 63, 62, 61. That's the same thing as 63 factorial. And on the bottom, you're going to have 63 factorial. So these two will cancel out, giving us 1s. And all we would have to do to get this humongous amount of calculating would be to just multiply 65 times 64, and you've got your answer. Even with a calculator, it might be easier. Yes, I think so. This next one, what is that there for? Well, it's to remind you that you have to do what's inside the parentheses first. So what this amounts to is 5 factorial over 2 factorial. It has nothing to do with 5 factorial here or 3 factorial there. No. It's 2 factorial because you have to evaluate what's inside the parentheses first. On the last one, You've got 6 factorial, okay. And on the bottom, remember, if we made that fraction, this becomes easy. You have 2 factorial, that's already there. And the second one, since you work out what's inside the parentheses first, you've got 4 factorial, put in your calculator, boom, you've got the answer. So there's the first one, 5040. And that's what it would look like on your screen. You put this into your calculator, hit enter, and you get the result on the other side. The other one, remember the bottom is 1, so you don't even need to do that. In fact, you could conceivably do this faster in your head than you could on the calculator. 4 times 3, 12. Double that, 24, bingo. Got your answer. I dare you to start doing that. In fact, some of you, I expect, would have children. Imagine if your children can see that you can do something like that without even using a calculator. They'll be amazed, and it'll teach them a lesson. There's the 4 factorial over 0 factorial if you really had to do that. Notice that the way they have it on here, oh, that is so old stuff. Unless you've got a TI-83, then it's going to look like this. But if you've got a TI-84, you're not going to do that. You're going to make it into a fraction like this so it looks like what you're actually trying to find. There's how you get it. Hit the math key, go over to PRB. I think on some calculators it's PROB, but you get the gist of the matter. And there's a 65 factorial over 63 factorial. You can see what they did here. They canceled the 63 factorial on the top and the bottom, giving you 1s. And no, you're not going to do that in your head. If you can do that in your head, you're really fantastic. You must be some kind of genius. So there it is in the calculator, sort of. Someday maybe I'll actually reverse that, but you get the idea either way. There's the second one. Remember, this is important. Do what's inside the parentheses first, so that becomes 2 factorial, and then you're in business. There it is in the calculator. You can do all that in your head. And if you want to, you can actually do the 5 minus 3 in parentheses. It might be more trouble than worth, unless 5 minus 3 is a lot more complicated than that. There's the next one. You got 2 factorials in the denominator. You can see how this can be handy. You've got the 4 factorial on the top, which is part of the 6 factorial, which cancels the 4 factorial on the bottom. And you're ending up with 30 on the top, 2 on the bottom. There's your 15, which you could do in your head, couldn't you? Why not? There's your 15. We're rolling right along. We're talking about combinations and permutations in this lesson. The important thing here is, I'm going to swap these around, I think. Think of permutation first, because the important thing is that the arrangement is specific. Translated, order matters. Erase that. And that's for permutations. And for combinations, order does not matter. And we'll take a look at that in a minute. There's my addition to these slides. So you might want to remember that instead of what's on the original slides. Now, this is up to you. If you really want to do it the hard way, this is what the combinations and permutations are. Where order is not important, you're talking about combinations, and that means you're going to have n items, but you're only going to take r of them. How many ways can you do that if order does not matter? Down here for permutations, order is important, and we're taking n items, we're picking r of them. Same n and r that we had up here, same idea. We're starting with this number of items, and we're going to pick r items. So put a number in there, maybe use your birth date or something. This would be the combination of n items taken 3 at a time. How many ways can you do that? This would be the permutation of, let's say, 8 items taken 2 at a time. How many ways could we do that? If we have 8 different marbles and we're picking 2 and we're going to put them in a particular order, how many ways could you do that? 8 different colors of marbles and you're going to pick 2. There's going to be a first marble and a second marble. Maybe you'll put a little mark on them saying, this is the first one, this is the second one, to make the order matter. Here are some different representations for how combinations are listed or defined in a textbook. I've seen all of these. The permutations, not too much different really. Those are just things you would see in a textbook. Here's an example. First of all, how many ways can you arrange the way they stand in line for the movies? Okay, arrange, translated, order, translated. How many permutations? Part B, how many ways can you choose 2 of them to ride in the car together? Well, in this one, remember, they're either in the car or they're not in the car. We're not saying where they are in the car, they're just in the car. So the order does not matter in this one. So, no order. Read through that again. It doesn't say anything about an order. It just says they're together. It doesn't say one's to the right, one's to the left, none of that. No order. So you're going to do this one with combinations. So if the arrangement of 3 friends is important, then line them up for a movie. If the order does matter, arrangement, that means you've got a permutation, you've got 3 friends, and you're going to line them up. You're going to take all your friends. You're not going to kick one to the curb. And you can calculate how many ways you can do that. 6 ways. Now we know you have more friends than that. But this is just an example, so don't get huffy there. Here we go with the calculator. You put the n number in first. To get this, you go to Math, Probability, it might be PRB, and then you go to for permutations. So first 3, then go through this, that'll put this part in there, then put how many you're actually going to pick out of the 3, and there's your answer. 6 ways you can do it. And this is an actual listing of how many ways you can do it. This isn't too hard with 3 friends. But if you had 16 friends, there would be a lot of ways that you could line up those 16 friends in a line. In the second part, order did not matter. Arrangement is not specified, so use a combination. We have 3 friends to choose from, and we're taking only 2 of them in the car. You can put in the formula, or you can put 3 in the calculator, go to math, probability, and 3 for combinations. And that'll put C and R here. And then you put in the 2 because you're having 2 friends. Hit the enter, and you'll get the 3. Just like that. And there are the 3 ways. I dare you to try to figure out any more ways more ways to put your friends in the car. Remember, they're just in the car. It doesn't matter where they're sitting or how they're sitting, left to right. Forget that. It doesn't matter. That's why it's combinations. And you could go to Hawk's Learning and look at the technology instructions for counting. I haven't, because I don't need to, and you don't need to either. If you're confused, another way you could do it would be you just contact me. You could stop in the office and say, hey, could you tell me how to do this? No problem. About 1 minute and you'd be in business. So if you're confused in the slightest bit, stop by, say hello, and say, permutations, combinations, I can't do them. In a couple of minutes, we'll have you straight. Special case. It's a special case because these numbers are the same. It means that order matters because you have the permutation. You have a certain number of items to choose from, and you're taking all of them. That's why it's a special case. Usually you have a certain number, and you're only picking some of them. Of course, the 0 factorial on the bottom is just a 1, so that's easy to work out. You could just go and put in n factorial if you recognize that. We've got another example coming up here. We've got 18 fifth graders, and we want to get a class president, a vice president, and a secretary. We need 3 offices. That's all we need. And does it matter? Yes. The class president is different from the vice president, and they're different from the secretary. So since they're different, it matters who we pick for the first one, second, and third. We're going to pick from the 18 fifth graders. We're going to pick out 3 of them for the offices. So we'll put in 18. We'll go to function, put in the 3, and then we'll enter 4,896. Sometimes this really amazes me. I've taught statistics before, I've taken statistics before, but sometimes the numbers just boggle me. Usually I wouldn't guess how many there were. That's why we have calculators, right? So here's the way you can do it. 18 NPR. That's what it looks like in the TI 83. And the 84 is even simpler to use in the TI Inspire. All you have to do is start with menu and see one of the items is probability. And the next thing you know, you've got the answer because it gives you a menu and says, how many do you want to pick from and how many do you want to get from those? Put those in, go down there and say OK, and you get 4,896. Next, we're going to the cafeteria. Does this make you hungry? Well, I'm not sure if it makes you hungry for carrots, green beans, lima beans, celery, corn, broccoli, and spinach. But we know one thing. We're going to have to figure out how many there are. So 1, 2, 3, 4, 5, 6, 7 different vegetables. 7 different vegetables. We know that'll be n, regardless of what. And Bill wishes to order a vegetable plate with 3 vegetables. So we want 3 vegetables. He's only going to pick 3 of them. and they're different. Now, how many ways can his plate be prepared? It's a combination because they're just going to be on the plate. You don't care. You can rotate the plate if you want to. That's perfectly fine. We don't care where they are on the plate. So it's going to be a combination, and we're going to select from 7 vegetables. We're going to get 3 of them. So put 7 in your calculator, pull up the combination, put 3 in the calculator, hit enter, and there are 35 ways Bill can do this. There's a summary of what the calculator would look like if you're using a TI-83. The TI-84 might look similar. It might have this part the same or a little bit different, but you would recognize the difference if you looked at this and looked at what you got from a TI-84. Next, are you ready for a little baseball? Well, Little League baseball coach is going to select the starting players. And that means we're going to have 9 players on the field. We need a batting order for those 9 players. It's our second game, and we want to find out how many ways those batting positions could be selected. Well, first of all, how many baseball players do we have? The only number we have here is a 9. There's a 9. How many is he going to pick? Well, as long as they're going to play the game, he'd better play all 9 of them. Does it matter? Oh, there's your answer, order. So it's permutations. So you'll put in 9. Go to permutations. Put the 9 for how many you're selecting. And, oh my gosh, did you think that there'd be 362,880 different ways to create a batting order? Isn't that something else? I wouldn't have expected that, would you? You could play baseball for a long, long time, almost 1,000 years, 1 game per day for almost 1,000 years, and have a batting order different just from those 9 players every single day. Try to wrap your head around that. There's your selection, 9 players to choose from. You're putting all 9 in the batting order. Since the order matters, there's your permutation. And when you hit enter, 362,880. Okay, so what's the probability that randomly choosing you'd get the same order for the second game? Well, for the second game, there was only 1 order in the first game. So what's the chance of having exactly the same order? There was only 1 way to get the same batting order, and there are 362,880 ways of picking the second batting order. Chances are pretty slim if it's done anywhere near random. Next, Maya has a bag of 15 blocks. All of them are different colors. And it includes red, blue, and yellow, and others. So she's got 15 blocks. She's going to pull out 3 blocks. Does it matter what the order is? Well, do you see order up there anywhere? No, she's just going to pull out 3 blocks and maybe throw them into a bag or into her pocket or just throw them on the floor. Doesn't matter. Since it doesn't matter, it's a combination. We're picking from 15 blocks. We're going to get 3 out of those blocks. How many ways can we do that? 15 blocks, choosing 3 of them. They're all different. We don't have a combination of reds, blues, and yellows. We've got 15 different colors. 455 ways. So did you think there was more than that? It's up to you. There's how you get it with the TI-83, 84. And the TI Inspire isn't too much different. So you hit Menu, go to Probability, pick out the combinations. Next thing you know, they're giving you a menu. You can put in the 15 and 3 where you need to. Bingo. 455 is your answer. Next. Oh, that's just changing it to a probability. Got one way for each one of those combinations. And you got 455 ways converged like that. By the way, just a small tip. If you want a decimal version and the calculator is showing this, the sneaky way is when you put the numbers in, put a decimal point either on that one or this one, and it's going to force a decimal answer. Okay. Special permutations. This is a little bit different. And I'll show you in a minute, but take a look at what the formula looks like. This is the total on the top, and the K's represent the parts. And all of these K's put together, the first one, the second one, and so on, add up to that total. So how do we use it? One way is pretty silly, but it's an example, so hang in there. How many ways can you arrange the letters in the word Tennessee? So first thing you do is, how many T's are in there? You go 1 T. How many E's are in there? 4 of those. How many N's are in there? 2. How many S's are in there? 2. I think I've got them all. 4, 2, 2. Let's see. 4, 5, 6, 7, 8. I think I've got them all. Okay. So you want to know how many ways you can do that? Well, first of all, get the total. There's 9 letters in Tennessee. So if you want to know the number of ways, you need N over K1 factorial, K2 factorial, and so on. In this case, we've got 9 letters, and we're going to have 1 factorial times 4 factorial times 2 factorial times 2 factorial. And after you've got that lined up, you can put it in your calculator like this. Remember to make it into a fraction. That helps. If you don't put it into a fraction, make sure you put parentheses around that. And there's your answer. That's how many ways we can make the word Tennessee using those. And there's how you do it in your calculator. Well, that's it for now. Back later. Bye-bye.